Hey folks, thanks for coming to the Enablement session today. Just a little bit of administrata first of all. It's been brought to my attention that only our partners who currently have an Okta account because they're on an engagement with us can actually only see the Zoom recordings. So a lot of folks have not had access to those. I am currently in the process of downloading those from Zoom Cloud, rendering them and then uploading them to GitLab unfiltered. So they will be available there. Keep an eye on the enablement notes and I'll put the link out for that. But it's usually just youtube.com, and then go to the search for GitLab unfiltered and we'll find them there. We're going to put them under a professional services enablement playlists. They should be all in one giant group and easy to view. Eventually, we will be going to the point of broadcasting these live on unfiltered as well. But until we work through some permission problems that we're having right now, we're just going to continue going the route of recording and uploading. I should have those uploads done in the next few days. I think the next piece for folks is we are going to go to an alternating schedule, and I will adjust the calendar to reflect that. We're still going to be every 2 weeks, but one session will be the early session, 7 PDT, and the following session 2 weeks later will be the noon one, and we'll keep doing that 7 noon, 7 noon, 7 noon. It just makes it easier on the presenters so they're not having to do double shifts during the day, potentially one very early in their morning or very in the middle of their afternoon, then one late or early evening. But it also makes it so folks have an opportunity to still join them at the same time occasionally. So, and again, all the videos will eventually be on unfiltered, whether those are the live stream ones, the ones we're uploading now. With all that out of the way, I will hand it over to JB, who's going to talk us through some SAML and SSO, I believe.
Yeah, we're going to talk about SSO. It's like my favorite topic. Okay. Oh, hold on. Let me move this. I forget how Zoom rearranges when you share your screen. So I'm going to try. I made some slides. They're very bad looking slides because I did not put any amount of time into them. And they're probably more than I can actually get through in an hour. So if I'm skipping around a little bit, I apologize. I'm making this up a little bit on the fly. But we're going to talk about SSO, and I wanted to kind of just go a little bit broader up front and talk in general about some of the authentication and authorization kind of features that GitLab has and how they tend to kind of line up with like what customers want when they come to us. I went to graduate school for this topic, and I get way too excited about mathematical formalisms for access control. So count yourself very lucky that I'm not going to like make you do an exercise about the Bell-LaPadula model. I'm going to exercise a lot of restraint and not even tell you what it is. So this will be the limit of our like kind of boring academic stuff, but I think this is kind of worth talking about because sometimes customers will ask about these kinds of things. So just some terminology. I am generally going to say one of the annoying things here, a lot of the terminology is inconsistent from like one technology to the next. So I am generally going to say principal. In a lot of cases, you might say subject. That refers to someone that is authorized, is authenticated. Often we'd say user. The reason that I try to say principal instead is because in a lot of cases that could be an automated process. That could be like a runner, some sort of third-party product that's integrated. There's a lot of different things that a principal could be. And then an object is the other side of the subject-object relationship. An object in GitLab is generally going to be like a project, something that's in the repository, an issue. They're things that a principal may or may not be allowed to interact with. Then two big terms to know, and I guarantee you I will use the wrong one at least once because they're similar words, and this causes a lot of headache, is authentication and authorization. People tend to use them interchangeably, informally, so what's the difference? Authentication is about identifying a principal, making sure that a principal is what they claim to be. Basically, that's like username and password is our authentication process. Then there's a whole separate domain of concerns, which is authorization. And authorization is about those subject-object or like subject-verb-object relationships. Authorization's whether or not a principal can do something. So when I log into GitLab and I'm now logged into my profile, that's authentication. When I go like look at a project and GitLab has to decide whether or not I'm allowed to see that project, that's authorization. It's really common to abbreviate these to authn and authz, and some horrible people like me will even say those aloud sometimes, just because they're long words and it takes a long time to write them. Couple other terms I want to talk about. When you get into like the formalisms, there's like mandatory access control, there's discretionary access control. That stuff doesn't really matter to us. What will matter to us a little more are like access control models or frameworks. RBAC and ABAC are like two things that I basically wanted to mention because you will sometimes have someone ask you, does GitLab do RBAC? And the reason I assert that is because there are like purchasing requirements in the federal government, for example, that like basically someone will say, we want to go ABAC. We are now going to require that software solutions either implement ABAC or get an exception. So these are like, these terms come around in the purchasing world sometimes. I'm not going to explain in a ton of detail like what they mean, but we do kind of have the permission model in GitLab is kind of weird when it comes to authorization. So we do have role-based access control. It's set up in kind of a strange way that doesn't really totally match the like typical formalisms. Role-based access control is basically a user has access based on their role. So if you're putting users into groups and then you're assigning permissions to those groups, that's like basically you're doing RBAC. ABAC, which is attribute-based access control, is an extension of that. The way I like to explain it is that you calculate the roles. So instead of like statically putting a user into some set of groups, under an ABAC model, you have metadata about users, and then you use that metadata to make authorization decisions. This stuff comes often out of the US government when people are like really caring about this. So my example, like a classic example of ABAC, is nationality and clearance level. Let's say that your user database tells you a user's nationality and their clearance level. In an ABAC system, you could have policies that looked at both of those pieces of information to say this person has a secret clearance and is a United States citizen. They are allowed to see this object. We don't really have that capability in GitLab. Some kind of weird things have been done to extend GitLab into that territory, but it's not something that we offer really out of the box. And then I just wanted to mention access control lists as an idea because I said GitLab's a little weird. We like kind of have a combination of several different ideas, which is really common. Like we're far from the only software that's like this. An access control list, there's a little bit of inconsistency around how the term is used, but it kind of refers to doing role-based access control the other way around. So instead of having a principal who you like place into a role, you have an object, and then against that object, you define what principals are allowed to interact with it. So it's like we can do it two ways. We can list what a principal is allowed to do, or we can list what an object is allowed to have done to it. And that latter approach is kind of the ACL. ACL is not so big anymore, used to be really big. Windows NT is like all in on ACLs for everything. Okay, so let's stop talking about that stuff, but just keep that in mind because it'll kind of come back around when we look at like what the actual capabilities of these different ways that we can do authentication are. So what is SSO? SSO is single sign-on. Sometimes we are all a little bit loose about like the terms that we use. So I think it's useful to separate out like what kinds of integrated authentication someone might want to do. In the olden days, most of what you would see was directory authentication, which is basically we have a central database of all of our users. And the way that you log into the software is that you provide your username and password, and the software checks that against our directory to decide whether or not you're allowed to log in. By far, like the most common directory authentication protocol these days is LDAP. And then you still see Kerberos. Kerberos it's like super cool academically and not super cool in practice. So you tend to only see it used as part of like an integrated product like Active Directory. We do have Kerberos authentication support in GitLab. It'd be interesting to see how many people use it. I think when you're doing directory authentication with GitLab, it is almost always going to be using LDAP. SSO, single sign-on, is a little different. So when we talk about directory authentication, that's like GitLab does the authentication, but it doesn't have its own user database. It looks at an external user database. With single sign-on, GitLab just like doesn't do the authentication anymore. GitLab totally defers to another piece of software to make an authentication decision about a user. And I wanted to talk a little bit about federated authentication because this was like a big like Web 2.0 era thing. And all of a sudden, every single website was like, do you want to log in with your Facebook or log in with your Twitter? That like technology stack was kind of designed for like consumer facing stuff because it was thought that people got annoyed by having too many accounts. But what's happened is that a lot of the technology that was developed for federated authentication has kind of been repurposed to be used for single sign-on because it sort of solves the same problem of like a totally different service can decide whether or not you're logged in. So what does that mean for GitLab? Single sign-on is like going to be, I think, the most popular thing with customers these days. I think every engagement I've done where they've done any sort of authentication that wasn't just the local in GitLab, they've wanted to do SSO. We support, actually, because we use OmniAuth, we support like a weird number of different SSO and federated login protocols. But most of the time, what's going to matter is SAML and OIDC. And we're going to talk about those kind of in the most depth. So concepts around single sign-on. So we talked about directory authentication. When you're doing single sign-on, I'm saying that that's not directory authentication, but typically there is still a directory, and whatever we're using is like the SSO identity provider is just connecting to that directory on the back end. What SSO introduces are the identity provider and the service provider. Those are SAML specific terms, but SAML seems to be the most common, and I'm just going to kind of try to use those terms instead of using like different words for the same thing. So the identity provider is the authentication service, and then the service provider is something that a user would actually want to use. That service provider term can be a little bit confusing. What this means in practice is that GitLab is the service provider. So when a user wants to log into GitLab, GitLab is a service provider. It doesn't do authentication. It kicks the user over to an identity provider to actually authenticate the user, which then sends the user back to the service provider. One funky little detail here that is handy to know about is that it can matter whether the login process is initiated by the service provider or initiated by the identity provider. What does that actually mean? If I just go to GitLab.com and then I hit the login button and I get kicked to Okta, that is an SP-initiated login because I went to the service provider first. If I go to GitLab.okta.com, look at the Okta dashboard and click on the GitLab button, that is an IDP-initiated login because I am starting in the identity provider. It used to be more common to see software that like only supported doing it one way or the other, which is weird. Fortunately, GitLab supports both, but you can kind of get like different bugs that happen depending on which way the interaction is initiated. So let's actually talk about how these work in practice. As I said, SAML and OIDC, those are the two most common SSO protocols that you're going to use. And of the two, SAML seems to be the most common. I said here SAML, which stands for Security Assertion Markup Language, if you really wanted to know. SAML is generally what you should use. Like if you're doing like a new customer engagement and they don't know what they want to do about login, I think SAML is almost always going to be the right direction to steer them. There are some downsides to SAML, but it's just generally kind of more mature and more completely supported in GitLab than really like all of the other options, including OIDC. SAML originated as an SSO protocol. So like kind of the big enterprise identity systems tend to be oriented towards using SAML. On the other hand, you have OIDC, which stands for OpenID Connect. It's very confusing to say what exactly OpenID is. If you remember the olden days of like 2007 when federated login was taking off, OpenID was one of the big protocols. OpenID Connect is a total version 2.0 of OpenID, which is based on OAuth. So I said here, OAuth 2.0 and OIDC, they're kind of the same thing. They're not actually the same thing, but the way that they're different doesn't usually matter. If someone says to you that they want to do OAuth SSO, they probably mean OIDC. Because OIDC originated with like federated auth, I would say more software supports OIDC than supports SAML, but it tends to be software that is not explicitly like enterprise identity software. So the perfect example there, GitLab itself is a full-featured OIDC IDP. So if a customer wants to, they can have their users log into other software using GitLab. I don't think that's super common in practice, but we do use that feature pretty regularly because there are a number of third-party integrations that take advantage of the OIDC IDP feature that GitLab has as a way to authenticate users. I have to turn my headset just turned off in the middle of a meeting. It's insane that it would even do that. So that's like our cast of characters is SAML and OIDC. How do they actually work and how are they different? OIDC is all about passing XML diagrams around, or XML documents around. This is a sequence diagram that I didn't make. I stole this from Okta. Thank you, Okta, for your hard work. If you look, so the end user is in the middle. On the right is the service provider, which would be GitLab, and on the left is the identity provider. So the way that that SAML works is that the user goes to the service provider, assuming it's an SP-initiated login, which then kicks them back via a redirect to the identity provider. The identity provider does whatever it wants to do to authenticate that user, and then it redirects them back to GitLab, to the service provider. When those redirects happen, an XML document gets sent along with them. And that XML document, when the user is getting redirected from the SP to the IDP, it's basically configuration. It's the SP telling the IDP, here's what application I am, and here's like what SAML features I want. When the user is getting redirected from the identity provider back to the service provider, that XML document is called an assertion. The first time I should say it's called an authn request. But when they're going from the IDP back to the service provider, it's an assertion. The assertion is a longer document. It contains information about the user, and it's cryptographically signed by the IDP. So that's how GitLab knows that actually, like, this user isn't making stuff up. They have this signed document from the IDP that says who this user is and gives us some other information about them. That's why you have to configure GitLab with that fingerprint when you set up SAML, is you're telling GitLab what key is allowed to sign those assertions. This is the SAML flow. Next, let's look at the OIDC flow. I stole this sequence diagram from a different place, which is why it looks completely different, which is maybe undermining my point, but I want you to notice something that is very different about this sequence diagram from the SAML diagram. So first off, terminology. I'm just always saying IDP and SP. Those aren't correct for OIDC. For OIDC, it's the OpenID provider, or the OP, that performs authentication, and the relying party, or the RP, is the application that wants the user authenticated. So GitLab here is the relying party, and then the OpenID provider is whatever's being used for authentication. The user first probably interacts with the relying party, which then kicks them to the OpenID provider because it doesn't know who they are. The user authenticates against the OpenID provider, and then the user gets redirected back to the relying party. But here's the thing. With SAML, those redirects had those XML documents attached to them. With OIDC, those redirects are like just for the user's convenience so that they don't have to manually be like, I want to look at GitLab, but first I got to go to the OpenID provider. Now I can go to GitLab. They're redirected for their convenience, but that's not a means of communication between the relying party and the OpenID provider. For OIDC to work, the GitLab needs to directly connect to the identity provider. That's a big difference from SAML. So SAML's funny because SAML involves XML, which is always one of those like, oh, this is going to be kind of a headache, isn't it? But in my opinion, OIDC is actually more complicated and more difficult to troubleshoot than SAML. And the big reason there is because with SAML, the user sees everything. Like the authn request, the assertion, the user gets a copy of those. And when you're troubleshooting, you can just look at them. With OIDC, it's a little different because a lot of the process actually happens behind the scenes from the user perspective. And if it doesn't work correctly, now you've got to start looking at logs. It's a little bit trickier to troubleshoot OIDC. That's like one big difference to know between SAML and OIDC. There's a couple implications of that that'll come up later. Another big difference to know between SAML and OIDC has to do with how session duration works. SAML was built under the assumption, well, first, why do we care about this, right? The reason this comes up a lot is when you have an employee who goes bad and you fire them and have security escort them out of the building, right? How do you have security escort them out of GitLab? That's usually the concern that comes up here. SAML was designed under the assumption that the IDP would be proactively involved in managing sessions in the applications that are used. So the like proper SAML solution to this problem is something that's often called single sign-out, or sometimes people will call it IDP-initiated sign-out. The SAML protocol specifies that an IDP can tell the application, this user's no good anymore, kick them out. GitLab doesn't implement that endpoint. So the protection that we have in GitLab, and this is not unique to GitLab. Like, I don't like that GitLab doesn't implement that endpoint, but it's far from the only application that doesn't. Instead, we have to go by session duration. So basically, when the user signs in, we basically figure they must be good for the next N hours. And then at the end of that, we'll basically make them log in again. This is a little weird in GitLab. And I believe this is still correct, but I would have to go read through some issues to like totally promise you that this is still correct. SAML sessions in GitLab used to last for 7 days, but like everyone agreed that was too long. So it has been shortened to 24 hours. You'll still find open issues about this that say 7 days just because they were put in before that change was made. The kind of weird thing is that it's very tricky to configure that timeout, and it's not even really documented very well that that timeout exists. So it's handy to know, just like the out-of-the-box behavior from GitLab is that when a user logs in via SAML, they are good for 24 hours. SAML actually specifies a way for an IDP to tell an SP how long a user should be trusted for. GitLab doesn't currently implement that. There is an issue open to add that support. I would like to see that added because that's kind of the real solution to this problem. One of the reasons for that that's pretty cool from like an academic perspective is it allows the IDP to actually make a risk-informed decision about how long the user's session should be valid, which is probably not in practice something that many customers would use, but it's pretty cool to think about. You can say like, well, this user is logging in from some weird location. This is kind of strange. We're going to give them a short session validity just to play it safe right now. OIDC, very different how this works with OIDC. This is one of the ways that OIDC is actually kind of more complicated than SAML. With OIDC, when a user authenticates, they are given a short-lived token. What short-lived means depends on the IDP. 15 minutes is reasonably common. 60 minutes is also reasonably common. I think when you use GitLab as an IDP, 60 minutes is the value that gets used. Obviously, we don't want to make the user log in again every 15 or 60 minutes. So OIDC incorporates this mechanism called a refresh token, which is basically a special token that the service provider is given that allows the service provider to redo just the like backend part of its interaction with the IDP. So the like logical idea here is that when you log into GitLab via OIDC, you get a real auth token that's good for 60 minutes. At the end of 60 minutes, that expires, and GitLab isn't necessarily going to trust you anymore. But GitLab knows who you are because you've still got your like session cookie that GitLab set up. So the reason GitLab doesn't trust you anymore isn't because GitLab doesn't know who you are. It's because GitLab isn't sure if you are still allowed to use GitLab. So the refresh token allows GitLab to go back to the IDP, basically say, is this person still good? And if you are, it can get a new short-lived token, basically without you, the user, being any the wiser. And then usually that refresh token can be used to refresh your session a certain number of times. It might be an unlimited amount of time. It might be for up to 24 hours. The IDP gets to decide because basically at some point GitLab goes back to the IDP, gives the refresh token, but the IDP says you can't get away with that anymore. We actually need to re-authenticate the user. So that's a big difference between the two. That OIDC thing, it seems to be okay these days in GitLab. There used to be a lot of like issues about this not working right. I think that's pretty much been smoothed out, but it's a good thing to know. Finally, finally, as we list a bunch of protocols at least, how does SCIM fit into this whole thing? Because this is kind of weird. This didn't make sense to me for a while. The thing about these protocols that we're talking about is that they're all ways for GitLab to authenticate you when you try to log into GitLab. These protocols do not tell GitLab when you hire someone and when you fire them, right? So when you log into GitLab with OIDC or with SAML and GitLab has never heard of you before, unless it's configured otherwise, GitLab will implicitly provision you, meaning GitLab will create an account for you on the fly because you tried to log in and the IDP allowed it. So apparently you're someone who should have a GitLab account. That's like, it's mostly fine. In a lot of cases, that works okay, but there's certain things that you might not like about it. One of them is that in some cases, you might be provisioning users through a different system than you use for single sign-on, and that system might have more information about the user. This sounds kind of dumb, but it happens in like HR systems sometimes. Sometimes the SCIM, like third party, is actually like a system of record that knows more about employees than the IDP does, which means that the SCIM system knows the employee's name and the IDP doesn't. So one upside to SCIM is that it lets you like have the system that knows the most provide the correct information about the user. You're not trusting the IDP to know the like metadata. Another cool thing about SCIM is that it deals with offboarding better. Because remember this scenario where you've got like an insider threat and you fire them, right? If they logged in via SAML, they've got up to 24 hours, basically, where they're still authenticated to GitLab. SCIM gives you a better solution to this problem because when you offboard someone, the SCIM provider can actually tell GitLab when it happens, this person has been offboarded. And when GitLab gets that information, it locks the account, which will stop the user from interacting with GitLab further. So SCIM is a good way to address those security concerns around offboarding users because it basically just makes the most sense. Like when you offboard someone, the software tells GitLab, GitLab knows right away and locks their account. Thing to know about GitLab SCIM implementation, like our SAML implementation, it is not a complete implementation of the specification. Once again, I don't like it, but it's not just us. There's a bunch of other stuff that's like this too. We only implement one of the API endpoints that is defined by the SCIM specification. It's the API endpoint for managing users. So how does that matter? There's kind of two things. Number one, we don't support the SCIM endpoint for managing group memberships. So SCIM applications are often capable of, when they provision a user, setting which groups they should be in and then updating that later on. GitLab doesn't support that, so that option is off the table for customers. The other thing is that some SCIM implementations want to auto-discover their configuration. GitLab doesn't implement the endpoints for that, so that doesn't work either. How big of a problem is this in practice? That'll speak to my next slide. I think we're actually not sure. I've been talking to the product manager about this, and it's just a little like, is this a problem for our customers? We're not 100% aware. But it's a good thing to know, because when a customer asks you, will X SCIM application work with GitLab? It's tempting to say yes, because SCIM is SCIM. Be a little cautious there. There are SCIM applications that won't work with GitLab because they require those auto-discovery endpoints. Authorization. So far, everything that we've talked about has been authentication. Well, except for the whole SCIM group thing, but forget I said that. Everything has been authentication. It's just, how does GitLab know whether or not a user is who they claim to be? There's also the question of authorization. How does GitLab know what a user can do? Traditionally, we manage that in GitLab by inviting people to groups, inviting them to projects, giving them different access levels. But a lot of customers might want to do that more centrally, because it tends to be better from a compliance and audit perspective to do all of your authorization in one place. Everything we've talked about has really been an authentication protocol, but that line can be blurry, and a lot of authentication technology kind of throws in a little authorization on the side. That's true of both SAML and OIDC. Both have a capability, it's an extension for OIDC, to convey to a service provider what groups a user is a member of or what roles a user has. This is an implementation of RBAC. Basically, the IDP is specifying a user's roles to us. GitLab doesn't support it for OIDC. I don't think it's a big deal, because it's not like so much stuff doesn't support it for OIDC that I don't think it's used that often. SAML, though, GitLab does support SAML role information. So remember, when you do a SAML login, you get redirected to the IDP, you authenticate, and then the IDP redirects you back to GitLab and sends an assertion document along with you. One of the things that assertion document can contain is a list of all the groups that you're in. We have a feature in GitLab called SAML group links, and that allows you to create a group in GitLab and then specify, if a user is in this SAML group, then they should automatically be added to this GitLab group with this role. It's a little weird because of this sort of like impedance mismatch of the authorization model in GitLab and the authorization model in most like traditional enterprise identity systems. But if customers set it up the right way, they can get like a fully managed system where everything for authorization is driven from the IDP. The IDP gives GitLab the user's roles in the customer's directory. GitLab then uses those SAML links to correctly place the user in the right GitLab groups with the right privilege level. One more thing to be aware of there are SAML group locks. Basically, what the SAML group lock feature does is it makes this whole thing mandatory. When you're just using SAML group links, any group with a SAML group link is now going to be fully managed by SAML group links, meaning you can't add users to it manually. They have to be added by SAML. But subgroups and projects, that doesn't apply. Users can still be directly invited using GitLab. If you turn on SAML group block, which is an instance setting, it like totally puts a lid on that. No one can be invited to a group or project in GitLab. It has to happen via SAML. So for our most like security sensitive customers, that's probably what they're going to want to really lock things down. To use SAML, set up SAML group links, and then enable SAML group lock. And now all the authorization comes from one place. So that's like all of the theory. How does this work in practice? If you read our documentation, you will find out that we support SAML for Okta, Azure for SaaS only, Google Workspace, and OneLogin for SaaS only. For OIDC, it's GCP and Azure. That is self-managed only across the board. Azure, that's also MSIP, not just Entra. MSIP is this other, it doesn't even matter. There's an extra thing you can do with OIDC against Azure. And for SCIM, we support Azure only for SAS, I think, and Okta for both. You might be thinking, that sounds like a surprisingly short list. This is like some of why I wanted to give this talk, because I'm going to start nagging people about this in Slack. I got kind of frustrated with our SSO documentation for like how little it covers in terms of how to actually do third-party setup, which means that you often have to kind of like usually you can get it to work, but you end up having to like brute force it a little bit, and you're like going back and forth with the customer with like, try this, try this. I really hate that. So I've talked several times now to Hannah Sutor, I think is her name, who's the product manager for this area. She is like totally fired up about making that documentation better. The problem is it's like so labor intensive for the authorization team to like have to set up all these different third-party products and then like validate and document. So that's kind of why it hasn't happened. So what I've talked to Hannah about is that in PS, we do this stuff like in the course of our engagements. We will often like, here's some IDP, let's see if we can get it working. So I kind of want to do this for everything, but I think like SSO is a logical place to start. I think we should be able to set up kind of a feedback loop between PS and the documentation, where if a customer wants to do something that we don't have documented is working, which is going to happen especially a lot with SCIM, since we like barely have any documented this works for SCIM, and then we try it, we should collect information on at least whether or not it worked, and then feed that back into the documentation. Ideally, I would like to have play-by-play, here is exactly how you set it up for different third-party software. But I also get that like it's labor intensive to put that together when you're working with a customer. So something that I've talked to Hannah about is that if nothing else, just a table of we have tried this and we know it works, even if it doesn't tell you exactly how to set it up, is better than what we currently have. So I'm going to think more, and I'm totally receptive to input about like how to get more formal about trying to capture that like knowledge that we learn in PS and then turn that somehow into like merge requests into the documentation. But at least for the moment, like just try to start thinking about that. And when a customer asks you, like, can we integrate GitLab with X thing that you've never heard of before, that should like spark a thought in your brain, right? That if you try it and you get it to work, or if you try it and you can't get it to work, let's like capture that information. Because that's really valuable for improving the documentation. Also, like when we're scoping engagements and stuff, right? So we don't tell someone, sure, we'll try to do that when we know that last time we did it, we like never got anywhere. And I think maybe like if we develop some sort of more formal, like, you know, post-engagement review process or something, maybe this could be kind of a line item there of like, did you try any new third-party integrations? If so, have we captured them for future knowledge? For the moment, I put in here, just like tell me. If you set up an SSO thing, tell me how it went. Because I've got like a bunch of issues that I'm commenting in about this stuff. Oh, one other reason. I mentioned our SCIM implementation is partial, and we don't know how big of a problem that is. Like, same deal. I've run into one thing where it looks like we can't get it to work because we only have a partial SCIM implementation. But I think that's the first time that like product has heard there is actually a problem that comes about because of this. So it's another reason to capture this data is it's really helpful for the product managers to actually get some idea of like, are there real customers that would benefit from, like, for example, a completely standards compliant SCIM implementation? Okay, couple last thoughts. I'm wrapping this up. Geo. How does all of this interact with Geo? If you're doing Geo with a unified domain, everything's fine because as far as the IDP can tell, all the sites are the same software anyway. It just doesn't care about the difference. If you're not doing a unified domain, it gets weird. And this is an area where our documentation should be improved, and I need to just like find some time to sit down and do it because I have discovered the hard way how a lot of this works. When you have two geosites with different domain names, you should not expect SSO to work to the secondary site. The reason being that the IDP will probably consider the secondary site to be a separate application from the primary site. And most IDPs, for good reasons, won't talk to an application if they don't know about it. For SAML, specifically for SAML, there is a special case written into our OmniAuth implementation that makes it possible to get this working. You will have to configure the IDP to recognize the URL of the secondary site as an additional ACS URL or reply URL. And you will need to not specify the ACS URL in the GitLab configuration. Because if you let GitLab guess the ACS URL, it'll do the right thing. If you're on the secondary site, it will use the URL of the secondary site. If you explicitly configure it, that overrides the guessing behavior, and the secondary site will use the primary's URL as its ACS URL. And if you don't know what the ACS URL is, don't worry about it too much. It's just one of the things our documentation tells you to set. The important thing is that the ACS URL is where the IDP will redirect the user to after they log in. So if the IDP gets the primary's domain name as the ACS URL, when the user tries to log into the secondary, the IDP will send them to the primary instead, and they're still not logged into the secondary. Does not work for OIDC. So just like if you're trying to do this, then like feel free to talk to me because I like know the details of how to get this to work. Just be aware specifically with SAML, you can get SSO to the secondary to work. There's some like extra catches that you have to be aware of that our documentation doesn't make as clear as it probably should right now. Then like a little bit of just a junk drawer of some things that are useful to know about SSO. This is like basically troubleshooting stuff. Common causes of problems would be assertion attributes with SAML. SAML is a very long standard, which means, of course, that it manages to not cover some of the obvious things that it probably should. And one of the things that it doesn't really cover is the names of the assertions. So is it first name one word? Is it first name with an underscore in it? That's a little iffy. It just kind of depends on the IDP. When you set up SAML in GitLab, you can specify a mapping of assertion names in SAML to profile field names in GitLab. Just to make things extra confusing, when you set up the application in most IDPs, like when you tell the IDP GitLab exists, you can also usually set up a mapping in the IDP of the IDP's internal names for fields of user information and the names of assertions. You have to get those two mappings to line up with each other so that the IDP puts the user's first name in the assertion name that GitLab will then map to the first name field in the profile. It's kind of common to have those just be a little like mixed up, like just something's wrong. There's an underscore where there shouldn't be. If you look in the GitLab documentation, by default, if you don't configure a mapping, it has a list of default assertion names that it checks for, which means that in a lot of situations, you don't really have to worry about this. Often the defaults just kind of get it. But email seems to be the weird one. Azure, or I should say Entra ID, is fond of using a kind of weird assertion name for the user's email address. It's like a full URL pointing at an XML schema that Microsoft uses. So really common like manifestation of this problem is that you log in with SAML and GitLab gives you an error message that says email can't be blank. Go check your assertion mappings. Probably GitLab is not trying the right name for the assertion with your email address. A really good way to troubleshoot this is one of the nice things about SAML. The user sees the assertion, but it's in a weird format. It's like base64 encrypted with a static key. So for both Firefox and Chrome, there are extensions that have a name with some variation on SAML debugger. handy to use one of those extensions. It will decode the assertion for you. So it basically works like your developer's tool panel where you have the network requests, but it flags the network requests that have SAML documents. And when you click on them, it shows you the actual XML. That way you can just look at the assertion and see what the names of the fields are in it and make sure the mappings are right in GitLab. Another thing to know is network connectivity. Remember, the flows are different. So for SAML, GitLab does not need to be able to talk to the IDP. The only thing that matters is that the user can talk to both. For OIDC, it's a different story. GitLab needs to be able to talk to the IDP, and probably the user needs to talk to both. Otherwise, how are they going to do it? Groups. There's a little bit of weirdness around groups. Remember, OIDC, it's a weird extension to convey groups that we don't support, so it's not going to happen with OIDC. For SAML, most IDPs are capable of sending the user's groups, but don't do it by default. So you likely manually have to put a mapping in the IDP side. And then in GitLab, it's the same deal. GitLab, I believe it automatically checks groups, capital G and lowercase g, but you might need to set up a mapping explicitly in GitLab just so it knows the name of that assertion. Some IDPs are weird about what they put in the groups assertion. It may not be the name of the group. It may be an internal ID, which is a GUID. That's annoying. Azure, you can actually configure either way, which I don't think our docs mention. That's probably a doc enhancement that we need. But sometimes you might just have to deal with doing your SAML group links in terms of like GUIDs, even though it's annoying. Session and timeout weirdness. I don't think you're very likely to see this anymore because it seems like the bugs around this are fixed. But if you ever have a customer complain that they're getting logged out of GitLab ridiculously often and they're using OIDC, something about refresh tokens isn't working. That'll hopefully give you like a good direction to start that troubleshooting. It could be that GitLab doesn't have the right endpoint URLs for the IDP, so it is managing to log in the user, but it's not managing to refresh their short-lived token. Finally, this is like seems to be a common source of support tickets. User sets up SSO, then discovers that their users are constantly getting their accounts locked. Probably this isn't a skim problem. It could be a skim problem, but it probably isn't. I don't think there are that many situations where a skim application is going to be like sending user deprovisions for no reason. And we also have some safety precautions in place there. GitLab ignores a skim deprovision unless the user was originally provisioned via skim. So there's a little bit of like a safety stop there to avoid a situation where you configure skim wrong and then it does something weird and all of your users are suddenly locked out of GitLab. A more common cause of this problem seems to be the combination of the required groups option to OmniAuth and a mapping issue with SAML assertions. So OmniAuth allows you to specify required groups, which basically means if the user isn't in this group, where a group is an IDP group, not a GitLab group, they aren't even allowed to log in. The way GitLab behaves, if a user who already has an account logs in and they're not in the required group, GitLab locks their account. So one of the ways this seems to happen is that a user sets up a group in their IDP that's called like GitLab users. And then in their GitLab config, they configure GitLab users as a required group. Then they start messing with their SSO config because they're switching IDPs or something, and they get the group mappings wrong. So GitLab no longer receives the list of groups because it's not in the assertion or it's in the assertion with the wrong name or something. Now all of your users are getting their accounts locked when they try to log in. So if you have that customer complaint, look at the SAML, the group mappings. That's like a good bet. There also maybe seems to be some kind of bug. There are like support tickets that have come up about this where I'm not sure that we totally got to the bottom of what was happening. So keep that in mind too. If it's real weird and you can't figure it out, maybe look at support ticket history and stuff. There might be something weird going on with a specific IDP. Maybe you found a product bug. Not totally sure. I think that's basically the end of my spiel. If you are weird like me and you want to like experiment with this a bit, which definitely helps with learning it, Keycloak is an open source identity provider. It is reasonably easy to get working. It's kind of a Java monstrosity, but it comes as a Docker image that I've spun up before in my sandbox cloud without many issues. Keycloak supports both SAML and OIDC, so you can try it out both ways. I mentioned that typically your IDP is talking to a directory, like on the back end. Keycloak is often used as an IDP with Red Hat IDM as a directory. Keycloak is commercially supported by Red Hat as part of their like enterprise identity platform. A lot of like government customers or people with big on-prem environments use Keycloak for that reason. But a handy thing about Keycloak, it actually has a basic built-in user directory. So if you just want to like test out SSO stuff, you can use Keycloak for the whole thing. You can just create users in Keycloak, which is way easier than getting Red Hat IDM set up because it is not a quick and easy Docker image to spin up. So that's what I'd recommend if you want to experiment is set up Keycloak in your sandbox cloud. You can configure GitLab with multiple SSO providers, so you can set up OIDC and SAML, see if you can get them both to work. And I think that's it. I like took up all of my time, so I have to jump soon. But are there any questions?
I was just gonna say thank you, JB. As someone who doesn't know much about any of this is super informative. Also, just share those slides out in the meeting doc and to me, because I can at least start with the MR in our PS docs somewhere and find a home for it. Because there's a lot of good stuff that I'm sure our engineers run into. And I will come back to you for cleaning it up and review, but I can take on the initial work of that.
Cool, thanks. I'm going to comment too on what Nikki said, which is GitLab.com or self-managed. I probably should have mentioned this. In a lot of cases, we support SSO two different ways. We support it at the instance level, or we support it at the level of a top-level group. And we do that for SaaS, so that SaaS users can have SSO. It is the same underlying implementation in most cases. Like it's the same like Ruby OmniAuth gem that's doing the work. So if you look at our documentation, you will find there's like SAML for self-managed and SAML for GitLab.com groups. They are two different documentation pages. That's one of my complaints about the documentation right now. That can make it confusing. Most of the time, something that you see in one of those pages probably also applies to the other because it is like the same code mostly under the hood. And that applies to like third-party support too. So like we only have it documented that Azure SCIM works for self-managed, or no, we only have it documented that it works for GitLab.com groups. I think everyone is like 99.9% sure that it works with self-managed too. We're just a little too nervous to like put that in the docs without trying it first, you know? So like same deal. If you see a third-party integration mentioned on one page, good bet it'll work in the other case. I talked to Hannah a little bit about like maybe should we get rid of the having two different pages about each thing. But like you can imagine, then that like creates a different problem of like where do you put the weird things that are specific to top level groups. So I'm not sure there's a clear win there. Oh yeah, LDAP. LDAP is a whole different deal. So
Thank you very much, JB.
awesome. Yeah. Thank you so much, everyone.
Thank you.
Thank you.
Thank you very much.